Hello students, welcome to the next video of derivative. In today's video we are going to see the logarithmic differentiation. Okay, so let's start. Sometimes some functions are found in complex form or their direct differentiation is not possible. The use of logarithm converts them either in sum or difference or product of two or more functions. Then the differentiation of the function is easy. Thus the differentiation of functions followed by the use of logarithm is called logarithmic differentiation. What this means, right? Two mathematical terms, two mathematical definition. So students, sometimes we observe that the given function is a very complex function. Okay, directly we cannot differentiate that function. So in such cases we convert that function in logarithmic form and then we differentiate that logarithmic function. Okay, so let us start with example. So before going to the example, let me tell you two cases, two very important cases. One, we use this logarithmic function whenever there is a variable raised to variable. Okay, or we can say function raised to function is given. Okay, any function of x or function of y. So whenever there is a variable raised to variable or function raised to function, then in such case we apply the logarithmic differentiation. Second is whenever we are having very complicated term, suppose we are having x plus 1 raised to 3, then 2x minus 1 raised to 2 upon root of x minus 1. Okay, why this term is complicated? Because to differentiate this, first we have to use u upon v rule, right? First we have to apply u upon v rule. Now when I am going to differentiate this u numerator part, then I have to apply u into v rule, right? When I am going to differentiate this denominator part, then I have to apply composite rule. Okay, so many rules in a single sum. So in such case we are simply use the logarithmic differentiation. We can convert this into logarithmic differentiation by taking log on both the sides. So now let's see some example. So see, question is find dy upon dx if y is equal to x raised to x. Okay, variable raised to variable, or it can be also written as differentiate with respect to x, only x raised to x. Okay, we have to differentiate this x raised to x, means variable raised to variable. So in this case what we are going to do, we are going to take log on both the side. So we will get log y, that is equal to x into log x. Okay, now log y, derivative of log y is 1 upon y dy upon dx. Okay, implicit rule. So derivative of log y will be 1 upon y into dy upon dx, that is equal to, now derivative of x log x. Okay, so u into v rule, x into derivative of log x, derivative of log x is 1 upon x, plus log x into derivative of x, and derivative of x is 1. So finally we will get dy upon dx as this 1 upon y will go on right hand side, so it will be y upon 1, so y into 1 plus log x. Okay, so that is equal to y is what? Y is x raised to x. So x raised to x into 1 plus log x. So this is the required derivative of x raised to x. Now let us see one more example. So question is differentiate sin x raised to 10x. Okay, sin x raised to 10x with respect to x. So here y is sin x raised to 10x. So that means function sin x is a function raised to 10x. Now again 10x is a function. So it is in the form of function raised to function. Okay. So now we'll take log on both the side. So we get log y, that is equal to 10x into log sin x. Now we will differentiate with respect to x. So derivative of log y will be 1 upon y into dy upon dx. Then 10x into derivative of log sin x is 1 upon sin x into derivative of sin x cos x. Okay. Then plus log sin x as it is into derivative of 10x. So 10x is derivative is sec square x. Okay. So finally what I am getting? I am getting 10x into cot x plus sec square x into log sin x. Okay. So that means 1 plus sec square x into log sin x. Okay. So finally dy upon dx, I am taking this 1 upon y on right hand side. So that will be y into 1 plus sec square x into log sin x. This is the required derivative. Okay. Let's see one more example. Here question is differentiate 10x raised to cot x. Again function raised to function is given. So we'll take log on both the side. So log y is equal to cot x into log 10x. Okay. Now differentiating with respect to x. So what I will get? I will get 1 upon y, derivative of log y is 1 upon y dy upon dx. Then cot x as it is, derivative of log 10x is 1 upon 10x into derivative of 10x sec square x plus log 10x into derivative of cot x minus cosec square x. Okay. So 1 upon y dy upon dx. Cot x into 1 upon 10x is cot x into sec square x minus cosec square x. Okay. This minus cosec square x into log 10x. Okay. Now cot x is cos x upon sin x. Again cot x is cos x upon sin x. Sec square x is 1 upon cos square x minus cosec square x into log 10x. So cosec square cancel. So what I am getting? 1 upon sin square x means cosec square x minus cosec square x into log 10x. So cosec square x common. So y into cosec square x into 1 minus log 10x. But y is what? Y is 10x raised to cot x. Okay. So this is the required derivative. Now see one more example. Here y is equal to sin x raised to log x. Now again function raised to function is given. Hence we take log on both the side. So log y will be log x into log of sin x. Now differentiating with respect to x, we get derivative of log y 1 upon y into dy upon dx. Now log x into log sin x. So u into v rule. So log x into 1 upon sin x into derivative of sin x cos x plus log sin x into derivative of log x 1 upon x. So log x, then cos x upon sin x is cot x, then plus 1 upon x log sin x. Okay. So finally dy upon dx will be, I am taking this 1 upon y in right hand side and substituting y as sin x raised to log x. So sin x raised to log x into cot x plus 1 upon x into log sin x. So with this, I'm concluding this video. So thank you, students.